Let's go to level 38, finding the zeros of the absolute value function. The zeros are where it crosses the x-axis. I'm going to set this equal to 0. To find the zeros, I'm going to set my f of x or my y equal to 0. We have 0 is equal to 5 times the absolute value of x minus 12 minus 7. I want to get rid of this minus 7. I'm going to add 7 to both sides. That gives me 7 is equal to 5 times the absolute value of x minus 12. I want to get rid of the 5. It's multiplying the absolute value bracket, so I'm going to divide both sides by 5. That gives me 7/5 is equal to x minus 12, or 1.4. So the absolute value of x minus 12. We have to deal with this absolute value bracket. Before we do, let's just look at a little bit of theory here. Right, so let's say we had the absolute value of x was equal to 2, or 2 is equal to the absolute value of x. That means that you take the absolute value of something, you're going to get 2. What do you take the absolute value of to get 2? 2, but also negative 2. The absolute value of negative 2 is 2. Whenever you have an unknown inside an absolute value bracket, you have to do a plus minus. X must be plus or minus 2. X minus 12 must be plus or minus 1.4. Then I want to get rid of this minus 12. I'm going to add 12 to get rid of it, but I do it to both sides. We end up getting 12 plus or minus 1.4 is equal to x. So our x1 is going to be 12 minus 1.4, which is 10.6. Then our x2 is 12 plus 1.4, which is 13.4. These are the zeros. Let's have a look at what this looks like. Our vertex is positive 12, negative 7, positive 12, negative 7 is right about here. And it's opening upwards. Let's go and find those values. I'm going to put in positive 12, which is my vertex, the x value of the vertex, and I'm going to do is equal to 5 times the absolute value of that x value minus 12, close the absolute value bracket, minus 7. And then if I press calculate, we get minus 7. So that's our vertex, 12 minus 7. I want to see what happens when x is 9. We get 8, okay? When x is equal to 9, we're getting 8. When x is equal to 13, we get negative 2. 13 is right here, is at negative 2. 14 is positive 3. So 14 is positive 3. 15 is 8 again. This is what it looks like, and it's going to keep opening up forever. Our zeros are 10 point something, which we've calculated to be. Our x1 is 10.6. Our x2 is 13.4. 13.4. And notice here is 10, 11, 12, 13, and that looks like 13.4. And that is your answer. You don't have to graph this on this level, but it gives you a good idea of whether or not you're right or wrong. Okay, so the graph confirms that we were right about the zeros. All right, and let's press answer to see if we are correct. Let's do another one. The vertex is at positive 10, positive 5, positive 10, positive 5 is right there. It's opening up. All right, so let's just draw that. I'm going to make my x value equal to positive 10, and the y value is going to be negative 5, is equal to 20 divided by 3 times the absolute value, the x value, take away 10, close the absolute value bracket, plus 5, and that will give us 5. All right, when it's equal to 9, we get 11.6. When it's equal to 8, we get 18.3. When it's equal to 7, we get 25. 725 is right here. If we go 3 on the opposite side, we should also get 25. What do you notice about the zeros? When is it crossing the x-axis? It's never crossing the x-axis, so there are no zeros. Let's look at this algebraically. If we set this equal to 0, set the y value, or the f of x equal to 0, we get 0 is equal to 20 divided by 3 times the absolute value of x minus 10 plus 5. I'm going to subtract the 5 from both sides. We end up getting negative 5 is equal to 6. Well, 20 divided by 3 is 6.6 repeating. Divide both sides by 6.6 repeating, and that gives us 5 negative divided by 6.6 repeating. That gives us negative 0.75. Here's the problem. The absolute value of something has to be positive. We have a total contradiction here. This is not possible. Here, we can see why it's not possible, because your absolute value is opening up. It never crosses the x-axis. You have no zeros. I'm just going to write none, and then press the answer to see if we're right. Similar situation, our vertex is at -11, -9, -11, -9, and it's opening down. Have a look at the other values just so we can draw it. -11 and is equal to -25 divided by 3 times the absolute value of the x value plus 11, close the absolute value bracket, minus 9, and that gives us -9 when it's equal to -10, when it's equal to -9, when it's equal to -8, when it's equal to -8, we get -34. Let us graph that, -8, -34 right here. That's 1, 2, 3 steps away from the vertex, and we go 3 steps on the other side. 1, 2, 3 should be here. When x is -14, we get -34. This is our absolute value function. Notice no zeros, none. If we did it algebraically, if we added 9 to both sides, this would become 0, so we would have 9. Then when we divide by -25 over 3, we're going to get a positive divided by negative is negative. The absolute value of something can't be negative. It's impossible. None. Answer to see if we're right. Here we're opening up. The vertex is at 0, 1. Here, opening up, there are no zeros, none. Here, the vertex is below the x-axis. It's opening up, so we're going to have some zeros. -8 and -6. Here, it's opening up. Let's get some other points. -8, y value is equal to 7 times the absolute value bracket. X value plus 8, close the absolute value bracket, minus 6, gives us -6, as predicted. Let's try -7. We get 1. -7, 1, 9, we also have 1. So it's going to be doing this, and we're going to get 2 zeros, and we can see them both here. Here we're at 8 point something close to 9, and here we're at 7 point and something very close to 7. Let us find those zeros algebraically. To find a 0, I'm going to set the y to 0, or the f of x to 0, and we get 0 is equal to 7 times the absolute value of x plus 8, close the absolute value bracket, minus 6. I want to get rid of that minus 6. I'm going to add 6 to both sides, because the 6 is being subtracted from all of this, which contains the x. Add 6 to both sides. That gives us 6 is equal to 7 times the absolute value of x plus 8. I want to get rid of the 7, which is multiplying the absolute value bracket. So I'm going to divide both sides by 7, like that. And that gives us 6/7, which is 0.857142, repeating, is equal to the absolute value of x plus 8. Now I want to get rid of the absolute value bracket. But remember, when we do, it means that x plus 8 must be either the positive of this number or the negative of this number. We have to put a plus or minus in front of it for that reason. Plus or minus 0.857142, repeating, is equal to x plus 8. I want to get the x alone. I'm going to subtract the 8 because it's being added to the x. So minus 8 from both sides. That gives us minus 8 plus or minus 0.857142, which gives us 8 minus that number is negative 8.8571442, repeating, giving us negative 8.857142. That's our first x value. And then the second one is negative 8 plus 0.857142, repeating, giving us negative 7.142857, repeating, is our x2. So let us go and see if that makes sense. We have negative 8.85, it's really close to 9, negative 7.114, something very close to 7, and there we are. These are our 2 zeros. The x1 is negative 8.8571442, and that's 6 decimal places, should be fine. x2 is negative 7.142857. Don't mix these up. The smaller of the two is your x1, and the bigger of the two is your x2. Then we press answer to see if we are right. And that's how you find the zeros of the absolute value function. Have a good day.